We're going to spend time in this chapter talking about two different kinds of change, the supply chain and the development chain. They're similar, but they're very different because the development chain, you really do it hopefully one time with your product, although you may actually go back and redo it a couple times to actually upgrade your product and keep it current in the market to make certain that you are meeting your customers' needs. So let's talk about this. For a lot of years, manufacturing engineer was the last stop in the project engineering the process. You sit there and sit down with a designer, work with them, develop the whole thing, hit out all the different aspects that could be out there, and hopefully your designer actually knows what they're doing. And it's one of these things of sometimes if you ever work on a construction project, you always wish that the architect would actually get out of their office and come out and spend a year out in the field trying to sit down and build the things that they claim that they're building design. Sometimes the people that write have no idea what happens in the actual process. You might come up with a design that all of a sudden has square corners, but you find out number one, it's cheaper to have rounded corners. Number two, it's actually from a customer perspective a little bit easier to deal with. And of course, from a machining perspective, those slightly rounded corners actually are easier to deal with on your machine and cheaper. So when you start looking at just here's my design, you need to implement my design, you have a problem because of the fact that that design may be more difficult and more expensive to implement as written than actually having no input at all. So a lot of times this is a top-down methodology. And if you study anything in management, a lot of top-down stuff doesn't seem to work. You need to have the input of the people that are actually doing the work an awful lot of times. So we have this whole thing is called DFM, design for manufacturing, where the manufacturing process is taken into account early in the design process. It's about the only way to make manufacturing truly efficient. Eventually, it does come around because if you really have a giant hit on your product, the actual aspect of you're going to get a lot of input, you would need to have things cranked out faster. You will get input in the process. But that said, sometimes your product simply may not take off just because you haven't taken the time out to go through and talk to those people at the other end. And those people are those in the manufacturing, which are a critical part of the supply chain. Sometimes they may not be able to get the actual raw materials the way you want them to be. Sometimes the actual bend in a corner, sometimes a simple little thing going out onto the shop floor, talking to people, making the stuff can actually make your project much easier, cheaper, and even better long term for the customer. So the supply chain focuses on the flow of the physical product through the whole system, from the manufacturing distribution all the way to the people, the retail outlets, and your final customer. The development chain focuses on the new product introductions. You have the architecture, the make and buy decisions. Geez, if I have it for this price over here, I want to hit my price point. My price point is $39.95. If we do it over here, you're trying to charge me $34 for this part, and I got to make profit on top of that. What are you doing? You're killing me. Well, if you do this over here, I can shave off $12 over here. And all of a sudden now you have this dialogue happening in developmental chain that you really don't normally have because your supply chain is usually something already preset because you have something cranking out on a regular basis. Developmental chain is brand new, and you're going to have a lot of decisions to make that might be extraordinarily difficult in the process. So you have to deal with demand uncertainty. You don't even truly know just based upon a cute little forecast made by somebody from marketing. Can you ever trust a marketer to sit down and make a great forecast? No, but you already know what the first rule in forecasting is. The forecast is always wrong. You learned that way back at the beginning. But you have also economies of scale. It's a matter of if you crank out 200 of these over here, the price is this much. If you crank out 1,000, the price is much lower. That's true because as soon as you get the hang of it down pat, going down the line, all of a sudden the price gets more inexpensive. And also the people that are doing it get much more expertise on actually doing the process, knowing how to sit down there and make certain they show up the next day, they tweak the machine one little way this way, you have that. You also have lead time. Now, sometimes the lead time is no big deal because the shop is down the street, but almost all the time the lead shop is not that simple. A lot of times now, you're actually going to India, you're going to China, you're going to Thailand, you're going over here into Africa, you're going over here into South America. Then all of a sudden, you have that supply chain aspect, and then you have terrorists over on the Red Sea. You have this group over here, they're invading this. All of a sudden, the Panama Canal has low water, and ships are getting stranded. So what are you going to do? It lengthens your supply chain, and really that lead time sit there goes right down the tank because of the fact that all of a sudden now it takes longer to get to where you want it to be because they have to have 10 more days of shipping. You have all these different things out there, and you have that bullwhip effect we talked about earlier, just whipsawing nonstop because of the fact that you have a change in economies of scale, a change in the lead time. You have all these different things on your clock speed because the technology too can kick in because all of a sudden now you have something new in the market. And now with AI kicking in, you may have different ways to get things done. And that clock speed is a big thing. And the patience goes faster, faster, faster. And if all of a sudden you have your actual real clock speed happening for the actual passage of time for your transportation going slower and slower, you have this collision of a perfect storm, and you don't want to be caught up in that perfect storm. You want to make certain where you're buying from. Sometimes it may be better off start going more modularization and having the pushing that out there, and that way you get that part done quickly. Look at your product structure, the level of modularity or integrality into the product itself. If you have a modular product and it's assembled from a variety of different modules, that might be a lot easier if you have a crisis, but it might be a lot easier in the development chain to go with a modular product. Although, if it's a new product, if you're dealing with what we call in the world business world a blue ocean strategy. In other words, nobody's ever done it before, and you're out in the ocean all by yourself. Now, they call the red ocean strategy when you're building a product that is already a saturated market. By red ocean, it's all the sharks biting each other. And by the way, the water doesn't stay blue if all the sharks are biting each other, it kind of turns red. So that's what we call it a red ocean strategy. But if you're blue ocean, where there's nothing out there right now, then you have really everything looks really good, except it's terrifying because there's nobody around you. You're on it by yourself. So the modular way, a lot of times, is a really easy way to sit down and have your development, and then you can actually customize it later on. It just depends where you're at, and you have to measure what you're making. There's two different kinds of general projects. You have a functional project. It's got a slower technology speed, low product variety, and typically low profit margins. There's not much there. We characterized that before with different types of things in the grocery world. You don't have hardly any technology in a banana. Okay, you might find the banana appealing because you like it a whole bunch, and a lot of people go ape over bananas. But all that being said, if you have a banana coming from South America, how many ways can you get the banana coming from South America to your local Trader Joe's store? Let's see. Ship, truck, plane. I mean, you could beam it there, but Star Trek still is a science fiction show. It's not real. So beaming is out. So you have to sit down and go by the functional products, the speed. There's almost no technology except you might get a new way to pick bananas, a new way to sit down there and wrap the stem with a certain plastic. That actually is new, but wait a minute, it's about 30 years old now. So you have that. There's different ways to actually deal with certain components of it, but no matter what happens, that will always be slow technology. Or all of a sudden, we got this new app. Let's hurry up, get out there. It's about trading with cryptocurrency. Quick, hurry, get up before somebody else does it. Yes, we get the crypto cash register right here. Ding, ding, ding. Let's go. And you have all of a sudden that you got a fast technology speed because if you don't get your app out there, somebody get their app out there, and it's going to be doing similar to things to you're doing. Hurry up, and you can implement it just like that. You can sit down there and people can buy it instantly off their phones. Two different ways of dealing with them. And also the clock speed is very different because you have a short product life cycle because technology always renews, always upgrades almost on an annual basis. The best selling product 10 years from now has not been thought of today. That's where we're at. So you have the functional products, you have the innovative projects. It just depends what you're making in the whole process. So pay attention to what is good for your supply chain, your different supply chain strategy, and your development strategy, which is the best one for you. Here's an example of some of the demand uncertainty about product introduction and product design. It just depends where you're at about the uncertainty. cell phone engines, okay, push systems, PC fashion, pulses. You have the whole different aspect as to what is demand. If you don't know the market, if truly your forecast is a shot in the dark, if you're dealing especially with what we call the blue ocean strategy, it's not in your textbook, by the way, but if you take one of the management courses in Entrepreneurship 211, we talk a lot about the different types of strategies, and the blue ocean is one of them. So it depends what you're out, but if it's got a low demand uncertainty, then it's just kind of going along. It depends if it's innovative or actually part of your functional. So pay attention to the overview of the design itself. Product and process design, a lot of logistic controls, economic packaging and transportation. Just a simple box is almost $2 now for a simple box with your company imprint on it. If you have a complex box with an insert, you can spend up to $4 more a box. It just depends where you're at. Pay attention to concurrent and parallel processing, one before the other, and how much can you standardize. You want to really pay attention also in the aspect and design as to how it's efficiently packed and stored. If you have a sloppy box and you got something rattling on the inside, you got a long appendage on your product and it breaks on the 20% of the time, you're in trouble as an organization. You have to make certain all the details, even among packaging, that the package can almost be indestructible as you can possibly make it, so you don't have returns, because you don't want to tick off the retailers at the end of the supply chain. So make certain you're out there. The final packaging, you want to sit down and delay until as late as possible. Really, the repackaging and the cross-docking point is common for a lot of different products. It depends where you're at. You want to really focus in as to what you're doing. Traditional manufacturing, they love to have the schedule set as early as possible because they don't want to have any idle machines. They don't want to have any idle workers because it costs them money. Large lot sizes make good use of equipment, minimize costs, and also take advantage of economies of scale, including on manufacturing. So concurrent parallel processing, the objective is to minimize lead times and also really achieve the redesign of products to make certain that everything is going to work out well long-term and have a cost efficiency to it. So to close the section about the supply and development chains, and the supply, ongoing products, development is new products, you need to focus in all the time on the functional and the innovative, and focus in on the design for logistics. Make certain your design is friendly with the manufacturer, also transportation, and how it gets through the supply chain logistically, and pay attention to concurrent and then parallel processing. It depends which one is best for you and your product development. Take care.